on Blackboard, just like the diagnostic one was last week. Same place. All right, once this recording starts, there we go. Let's go over these. So the first, 4 of these were determine whether or not the following are functions or not. If not, state why. So technically we don't need to say anything if it is a function, but I'm going to say a little bit anyway. So for this first one, x squared plus 1, if you were to graph this, you always have the choice to graph it if it's something that's easily graphable, especially in this, you could punch that into a calculator. This is going to look like this. So remember, for something to be a function, every input can only have one output. So essentially, all of these x values can only go to one thing, which in this case it does, so this would be a yes. Essentially, every x will only go to one y value. One kind of tip is if you have y equals, and there's no y's on the other side, let me just triple check my brain, make sure I'm not lying to you. No, if you've got y equals, that's going to be a function. The time where you'll see an equation, not necessarily that we will work with, but if there was an equation like y squared equals x, since the y is not by itself and it's not solved for, this is actually going to look like essentially a parabola turned on its side. That would not be a function. So once you start getting multiple y's in there, things get wonky. But if your equation just has one y, you can pretty much assume it's going to be a function. You might want to graph it and triple check, but it's pretty much going to be a function. So that one was yes. Technically, all you needed to answer the question was the yes, but I went a tiny step further. For part B, is this a function? So every input can only have one output. So this one is also actually a function. Now, it's perfectly fine that these are all 2's. The outputs can get reused. It's the inputs that can't go to multiple things. So actually, if we were to graph this, it would just be like a straight line up at y equals 2, which is perfectly fine because every one of these inputs only goes to one y value. They all go to the same y value, but that's fine. I'm going through these somewhat fast because you hopefully had already tried them, but if you have questions, feel free to stop me. For part C, and this is a little hard to see, but this goes out to 2 and -2 and upwards to 2 and downwards to -2. Not that that really matters. On this one's not going to be a function. And that's because essentially all of the inputs, except these 2 at the front and the back of the circle, have 2 outputs. So it's almost every input has 2 outputs. So let's get an example. So let's say, for instance, x equals 0 goes to, so x equals 0 is here, but it goes up to 2 and down to -2. It's got those 2 points on it. So that 1 point of x equals 0 goes to y equals 2 and -2. So since that one input goes to 2 outputs, we're not good. There's also something that we technically didn't talk about because we didn't need to, but you can use it if you want to. It's called the vertical line test. Essentially, if you drop a bunch of vertical lines on the graph, if it ever crosses more than once, it's not a function. So you could also say that this fails the vertical line test, because if you draw a bunch of vertical lines, a bunch of them will pass through more than once. So since tons of inputs on that will have 2 outputs each, that's not going to be a function. And then for our last one, we want to see if there are any inputs that go to different outputs. So we're looking through our inputs, and we actually do have a problem here. We have that x equals 1 goes to 1 and x equals 1 goes to 2. So this would be a no. And you could even just say x equals 1 goes to 2 outputs. Y equals 1 and 2. And you just need one situation where it happens for it to not be a function. So even though that's just one input that was bad, essentially, that makes it not a function. So the first 2 were yes, second 2 were no. Questions, concerns on the function question before I move over to the linear one? All righty. So then you are asked whether or not these two data sets are linear. So remember, for something to be linear, we're looking for a constant slope. That's kind of what we finished with the other day. So remember, I like to do these little kind of see how the things change and then compare their ratios. So if we look at the changes in x from 0 to 3, we go up by 3, and then we increase by 1, and then we increase by 2. Now remember, just because those don't agree doesn't mean it's not linear. We have to keep going. So let's check what the y's do. So the y's are going to increase by 6, and then by 2, and then by 4. I'm gonna slightly run out of space here if I don't write small. So remember, the thing we actually care about is the change in y over change in x, the slope. So we're looking at 6 over 3, 2 over 1, and 4 over 2. All of those reduced to 2, so these actually all equal each other. Where do I want to put my answer? So this is, this one's linear. So since all of those ratios agree, it's linear because it has a constant slope. So the slope here would be 2, just to go a step further. For the second one, if we check what our x values are doing, it's increasing by 2, then by 1, then by 2 again. Kind of block this off here. And then our y values are increasing by 6, by 3, and by 5. I think I've mentioned this before, my arithmetic is absolutely horrible, so if I ever mess up my arithmetic, just yell at me. Everything else in math is great, but my arithmetic's horrendous. 6 divided by 2 versus 3 divided by 1 versus 5 divided by 2. So the first two agree. Those both also reduce to 2. Sorry, 3 reduced to 3. They reduced to 3. But that last one, 5 divided by 2, is not reduced to 3. It reduces to 2.5. So since that last one does not agree with the first two, this table is not linear. The slope, that's not how you spell slope, is not constant. So if we're given a table, want to figure out if it's linear, check your changes in y's versus change in x's, compare all the ratios. If the ratios are all the same number, it's linear. If they're not all the same number, it's not. Questions, concerns on any of the warm-up before we continue along in this set of notes? All right, hold on a couple seconds in case people are still writing something down, and then we'll move on. All right. Okay, I'm gonna scroll now. So going, it's not scrolling anymore. There we go. Going to where we left off with problem 2 in this set of notes. So we want to look at, for each of the following situations, find and interpret the slope and vertical intercept. So for our first one, we have an icicle grows according to the formula 0.2 t plus 0.15, where t is the time in hours since the first measurement was taken, and wt is the width of the icicle in centimeters. So remember, when we introduced linear functions the other day, we have this y equals mx plus b format, where the m is the slope and the b is the y-intercept. So actually, since they've very nicely given us the equation, we don't really have to do too much work to actually find those two values. We just pull them off of the equation. So we have that our m, our slope, would be the 0.2. Never take the variable with it. Oh, it's lagging. Let me reshare my screen. That usually helps. It's too soon for lagging. Oh no, it's my laptop that's angry. I see. One moment. There we go. So the slope is the 0.2. You never take the variable with you. Okay, you never take the variable as part of the slope. That's not a thing. And then our b value, which is our y-intercept, would be the 0.15. So I'm going to interpret them in a second, but let's look at the units. I want to talk about the y-intercept first because I think that one is a bit more familiar to us at this point. So the y-intercept is going to be a y value, in this case a WT value. So the units on the WT values are width in centimeters. So this would be a 0.15 centimeters. And then for the slope, you have to think about the slope in terms of it's a change in y over change in x. So in this case, it would be a change in a WT over a change in t. So the units of the slope are kind of going to reflect that. So the units of the slope are going to be essentially the units of the y's divided by the units of the x's, or whatever variables you're working with in that problem. So here, since it's WT is centimeters and t is in hours, this slope is going to have units centimeters per hour. So I think I personally like to just lay out the units before I do my interpretation because it kind of helps remind me what the interpretation is going to look like. I think I'm going to do the y-intercept interpretation first, again, just because I think, again, that's a bit more familiar to us at this point. So for the y-intercept, remember that the y-intercept is technically a point, and it's technically when the other value is 0. So this would be essentially when t is 0, the other value is 0.15. So that's essentially going to tell us time is 0, width is 0.15. So it's essentially going to be the starting width. So I would say something like the icicle starts at 0.15 centimeters in width. If you wanted to say something like when time is 0, the icicle is 0.15 centimeters in width, perfectly fine. Again, I don't really care how you phrase these necessarily, as long as it has the right format and it gets the point across. So the format here would be one of the values is 0, the other one is 0.15. And, you know, I have the one value being 0 in kind of this statement as the icicle starts. Is kind of what takes care of that. The slope's a bit trickier. Not really, I shouldn't even say that. But what we want to think about with the slope is it's essentially a rate. So if you think about what the slope does in terms of a line, it tells you how much you go up when you go over, right? So it's essentially telling us how much we're increasing or decreasing depending on the sign of the slope. Since the slope here is positive, it's going to be increasing, so the icicle is going to be growing. So we would say something like the icicle is growing. Again, growing because the slope is positive. So the icicle is growing at a rate of that 0.2 centimeters per hour. There's a couple other ways you could phrase this, and we'll actually come back to this idea in a later chapter. So we'll kind of come back and look at other ways to interpret slopes, but that's a decent way to do it. It's essentially telling you that the y value context, so the width in this case, is growing or shrinking at a certain rate. It's going to be growing if the slope is positive, shrinking if the slope is negative. Questions, concerns about that? All right, so let's do the same thing with a slightly different situation. We've got an international travel data plan. Cell provider charges its customers according to a formula 10 plus 2.05 n. N is the number of megabytes of international data used, and C of n is going to be the total charge in dollars for 1 month of international service. So we're only going to be focusing on 1 month here so that it doesn't get, we don't have to worry about too much more. We just need to worry about that set equation. So we're just going to focus on the 1 month. So the slope here would be 2.05. Be careful. It's not just the first thing in the statement. So I know the original format is y equals mx plus b, but you just got to be careful. This case was written as b plus mx. So the slope is the thing that's attached to the variable. Y-intercept the thing is by itself. So let's oh my gosh, I can't talk. Let's look at units first. So the 10, the y-intercept would be essentially a y value of c and n value. So that's going to be a total charge. So that's going to be dollars. And then the slope, well, the slope's going to be a change in the C of n over a change in n. So the units of C of n are dollars, the units of n are megabytes. So that's essentially going to be dollars per megabyte. And I'll actually write it out, because why not? So if we want to interpret those, I'll start with the slope this time. So again, the slope is going to be a rate at which essentially the cost is changing. So it's going to change the cost at a rate of $2.05 per megabyte. And we're going to be increasing again because that slope is positive. So we would say something like the cost of an international plan is increasing at a rate of 2.05. I'm going to abbreviate it this time. Dollars per megabyte. And you could also like literally write out the words and not even like, I'm not even talking about something like I wrote over here. You could literally write out the words dollars per megabyte if you wanted to. And then for our y-intercept, remember the other value is 0, so we have n is 0, C of n is 10, so essentially 0 megabytes, $10. So that's kind of like the initial price of the plan without even having any megabytes attached to it. So that's actually how I'm probably going to phrase it. The initial cost of the plan, is $10. That's almost enough, but let me go a bit further and just clarify before adding any megabytes. So saying the initial cost of the plan is $10 is enough, but just to kind of clarify that you get no megabytes if you only pay $10. It makes it a bit better. Questions, concerns on that? All right. I'll wait a couple seconds in case people are still writing stuff down, but then we will do a new definition. Get through a few more problems. Yeah, let me try to keep some of that in there in case people still need it, but. All right, so the next thing we need to talk about is actually finding the equation of a linear function. So if we want to find the equation of a linear function, here's the process we're going to use. First thing you're going to do is you're going to find the slope. So remember, that's our y2 minus y1 over x2 minus x1. You're going to find a point that lies on the line. Sometimes you're given this. Other times you need to plug in an x value. So say you're not actually given a point that you want to have on the line, but you're given an x value that you want to go with. You then take that x value, plug it into the function to find its corresponding y value. Sometimes you'll have more than one point that you're given. You get to pick one, if that's the case. And then essentially you're going to plug into the equation and solve. And what I mean by that is we have our y equals mx plus b. So essentially what you would do is you would plug in your slope, your x value, and your y value and solve for b. There's also another way if you prefer. So this is what's called slope-intercept form, because it's got the slope and the y-intercept. There's another one I don't think people use as often, but it's the point slope form. And if you know it and you prefer it, my laptop's angry again. If you know it and you prefer it, then you can use it. But if you don't like it, then you don't have to use it. So the point slope form is y minus y1 equals mx minus x1. And if you do this, what you essentially do is you plug in m, and essentially your x value and your y value go in for the x1 and the y1. And then you usually solve for y. Sometimes people say you don't have to, and really don't have to, but it's good practice when you use point slope form to then just solve for the y value. Clean this up a little bit. There we go. I find that a lot of people are very used to the slope intercept form, so that's what I'm going to default to. But if you ever want to see the point slope form, let me know. It'll take 2 seconds for me to write it in that form too. So whichever form and process you prefer, you may use. So hold on a couple seconds for you to write that down. We'll do a couple problems on that, and then that's probably as far as we'll get. Wednesdays are gonna be weird. They go by real fast because we've got our warm-up and our quiz. So let me try to leave that part in at least. There we go. So say I want to find an equation for the line h that's drawn below. So we have this parabola and then we have that straight line, which passes through the two indicated points on the graph y equals -2x squared. Negative x squared plus 4. I can't read that right. -x squared plus 4. So it's essentially going through this point at x equals -1. And then we're not told what this point is, but it is going to be when y is 0. So notice that it's essentially the x-intercept of that parabola. So we do need to do a little bit of work here because I need to know 2 points to be able to find the slope. And I only know one variable in each one of the points. So I need to find out a little bit more information. So the first thing I'm going to work on is I'm going to work on this x equals -1 point. Let me find the y value for that. Because in that case, to find the y value, we just plug that sucker into the equation. So plug in -1. So -1 squared will be +1. So that'll result in -1 because the negative comes from the negative that was already there. So this will give us a y value of 3. So that essentially gives us the 1 point. So now we have a point -1, 3. So that's awesome. But we still need the other full point because we need to know the slope. And so for that one, we need to figure out what the x value is. So what we're going to have to do is we're going to have to set this equation equal to 0. And let me try to break this off a little bit so I save enough space for myself. So I would personally add the x squared over to the other side. You could subtract the 4, but then you would have to divide both sides by a negative, so it's one extra tiny step. And then here to solve that, we would have to square root that 4. Remember, whenever you square root something, you technically pick up a plus minus. So technically the answer to that is +2 or -2. So essentially this one back here would be -2 and this one right here would be +2. So we really only care about the +2 because it's the one that we need to use. But just for clarification purposes, remember whenever you square root something, you need a positive and a negative answer. So our point here would be 2, 0. So in terms of this question, we've done a bunch of work already and we haven't even done what they asked us to. We haven't even started finding the equation of the line. So now we have the 2 points we need, and now we can actually do the process for finding the equation of the line. So the first thing we need is the slope. So I need to find the slope between these 2 points. Remember, it doesn't matter which point you make your x1, y1, which one you make your x2, y2. I personally like to make the one with the larger y value be the first one, but whatever floats your boat. So I personally would do 3 minus 0 over -1 minus 2. Remember, if you put the larger y value first, whatever its x value has to go first as well. And, well, vice versa. Whichever y value you put first, you have to put its x value first as well. So we've got 3 over -3. So our slope is -1. And now at this point, we pick one of the 2 points. It does not matter which point you pick, you will get the same answer as long as you've done all the rest of the work correctly. So I'm going to choose 2, 0. I like it a little better than the -1, 3. So what we're going to do with that then is we're going to take our form y equals mx plus b, and we're going to plug in our slope and our x and our y values. So we have 0 equals -1 times 2 plus b. And then we solve for b. So we'd have -2 there. We would add the 2 over to the other side. We'd get that 2 would be equal to our b value. And then the very last thing you need to do is to just actually write the equation with the correct m and b value. So our slope was still -1. Our b value is 2. So our equation is y equals -1x plus 2. Of course, you could just write it as -x plus 2. That's usually how I'll write it. But that -1 can be there as well if you wish. Questions, concerns about how I found that equation? It did go through it somewhat fast, so let me know if you need me to go back through something. Okay, I'll hold on like 5 seconds. We'll do one more question, and then I think it'll already be time for the quiz. Let me see. Yeah. Is my brain working correctly? Yes, it is. Okay. All right, one more. Same kind of idea, we're going to find the equation of a line. So suppose we have the function 1 over t squared plus 7. Find a formula for the line that intersects the graph at -1 and 2. So we have this not linear graph, and we want to find a line that intersects this function at -1 and 2. So it's kind of similar to the last one where we need to do a little bit of work first because we don't have the full points yet. The quiz, you take it at the end of class, and it should be done by the end of class. I've never had too much of a problem with people not being able to complete it in time. If for some reason you think that's going to be an issue, let me know, but you should have plenty of time at the end of class to complete it. So the first thing we need to do is we actually need to find the rest of the point. So essentially we're given the two t values, we need to find their associated y values. So we need to plug in these two values into the function. So we've got 1 over 1 plus 7, so essentially 1 plus 7 will give us 8. And then if we plug in 2, that'll essentially be 1/4 plus 7. So I would leave it as 7.25. So now that we have both of the points, -1,8 and 2, 7.25, we can go about actually finding the equation in the line. So we need the slope first. Again, I personally like putting the larger y value first, but whatever floats your boat. As long as you make sure that whatever y value you put first, you put its associated x value first in the denominator. So we've got 0.75 divided by -3, which will give us a slope of -0.25. Now that we have our slope, we get to choose one of the points. So we can either choose -1,8 or 2, 7.25. Since one of them doesn't have a decimal in it, I'm going to pick that one. I think it's nicer. But again, as long as you've done everything else correctly, it doesn't matter which one you pick. We're going to plug it into our y equals mx plus b format. But because there's a t here, I'm going to use a t instead of a, well, I guess I'm not going to use it yet. But when we write our final answer, we will use a t instead of an x plus b. So we will have 0.25 plus b equals 8. Subtract the 0.25 from both sides. you'll get that B is 7.75. So then one thing that a lot of people seem to forget is to actually write the actual final answer. So remember, you don't just want to find B, you then want to actually put it in your final answer. So again, since the original variable was a t, I'm going to use a t. They didn't tell us that we couldn't use y, because remember, whenever you have the function name, you can think of it in terms of a y. So that's why I don't mind that. And really, we shouldn't say h of t. I should really actually clarify that. We shouldn't say h of t because h of t is actually that equation, not the line. So we should actually use y. But since the original x value variable was t, we'll have t. Questions, concerns about how I found that one? Okay. Then I don't think the quiz has popped up yet, so let me push it through. Now again, my quizzes are not meant to be something you're supposed to panic about. So it is up. Unlike the one from last week, there is a time limit on it. It's not going to automatically submit or anything after the time, but really it's mainly for me to make sure you're doing it in enough time. Like you should get it done before the time limit. For this quiz, there won't be a penalty if you finish it late. I might enact one later. Again, I don't mean to say that to freak you out. It's just you really shouldn't have to take more than 20 minutes. If you take more than 20 minutes to finish this quiz, you should figure something out. Yes, it's quiz 2. It's under the assignment tab on Blackboard. It says SP21 quiz 2. If you want to print out your guided notes, you'll just have to find a place to print them. I try to put them up on Blackboard with enough time for you to do them before class. But that's something you'll have to figure out how to take care of. But anyway, if you're ready for it, go ahead and take it. I would say stick around in here in case you have questions, but once you're done your quiz, you may leave. Have a great day. I'll see you on Friday.